You all know that engineering drawing is a method or discipline where technical details of a part, assembly or process is detailed in a graphical way. Engineering drawing can be interactive or generative. In interactive drafting, drawings are created without 3D models or 3D parts. It will have an interactive 2D environment. It can be used to add additional information to a drawing which is already created by using generative drafting. In generative drafting, drawings are generated from three-dimensional parts or assemblies. It is a 3D interactive environment to create solid models, and to create drawings there will be a 2D drawing environment also. And interactive tools are used to add additional information on the drawing. With this information, we'll try to construct few isometric projections using interactive method. First example, construct the isometric projection of a rectangle of size 40 mm into 60 mm. Now we can take 40 mm distance on any side of the isometric axis. First let us try to take 40 mm on the right side. Click on the line command and set the line thickness to 0.13. Draw a horizontal line, right click. Next I will start a 30-degree line from this point like this, but I want to enter this angle as 30 degree. I want to fix this angle as 30 degree. So I will go here and enter 30. But length, I have to fix it. I will take 40 mm length on this side. So I will fix the length also now. 40 mm 30 degree line is drawn. Next line I am supposed to draw like this, but that length should be 60 mm. And the angle from this horizontal reference, angle will be always measured from horizontal reference. So this is 0 degree. When I move the line like this, measures the angle positive from 0. So here the angle should be 150 degree. 150 means from here, this is 0, this is 90, and beyond that it should be 150 degree. So enter 150 degree here, and in that 150 degree direction you have to fix 60 mm length. So enter 60 mm here. 60 you enter like this. So your line is drawn. Next line, this line should be parallel to this originally drawn line, but the length should be 40 mm. So I will fix the length now and I will make it parallel. See, it is showing me parallel symbol. If the parallel symbol is not appearing, then you have to go to Tools, IntelliSketch, Relationships tab. If this parallel option is not ticked on, that option may not come. So make sure that this is ticked on. Now I can make use of this parallelism. I will just move the cursor onto this and I will say parallel like this. Click there and close it. This is what? This is the isometric view of the rectangle. I want to convert this into isometric projection by reducing the scale to 0.8164. So I have the scaling option here. Just below the move, rotate, mirror command is a scale option. So go to scale command. Select this entire rectangle by box selection method. So it's selected now. And enter the scaling factor here, 0.8164. Press enter and click at the same origin point. See, it is reduced now. Now it is an isometric projection of the rectangular lamina. You can show the angle here now. Angle between this line and this line should be 30 degree. Right click. Angle between this and this should be 30 degree. Right click. And you can make all these 4 lines dark because they are all visible lines. So select all these 4 lines and make it 0.5. That completes the isometric projection of rectangular lamina. If you want to interchange 40 mm and 60 mm, that is also correct. You can do it like this. I'll go for line command. We'll click here. Now I'll take 60 mm length. I'll press tab. I will enter 30 degree line. Press enter. Then I will enter length as 40. I will press tab button. I will enter 150 degree angle. Next I will enter 60 mm length. Then I will make it parallel like this. It's showing the parallel symbol. Click there and close it. This is the isometric view of the rectangle. I want to convert this into isometric projection by reducing the scale. So I'll go to scale command. I will select this entire rectangle like this. Selected now. Enter the scaling factor as 0.8164 and click at the same origin point. It is reduced now. You can show the angle between this line and this horizontal line and place it here. Right click. Select this line and this horizontal line and place it here. Right click. Now you show the edges dark. All 4 edges you select and make it 0.5. That completes the isometric projection of the rectangle. Similarly, you can draw the isometric projection of the rectangle on the vertical plane also. Now we have drawn it on horizontal plane. Next we will go to second example. Construct the isometric projection of an equilateral triangle of sides 50 mm. For which we need to construct the equilateral triangle of 50 mm sides first. Click on line command. Set the thickness to 0.13. Draw a vertical line of 50 mm. Click there. Next 50 mm length. You enter 30-degree angle and then just close it like this. Now it is a equilateral triangle of sides 50 mm. Now you have to enclose this inside a rectangular box. To do that, you go to line command again. Start the line from this corner horizontal till you get the vertical alignment from the third corner like this. Click there. Then click on this corner also. Then extend it beyond this so that you get a horizontal alignment from the other point like this. Click there and close it. Right click to end the command. Now this is the enclosure which encloses this equilateral triangle. Now we need to know what is the distance of this edge now. We'll click on dimensioning for this edge. See 43.3 is the distance of this edge. Now you can construct the isometric view of this rectangle 50 mm by 43.3. We will do that first. Draw a horizontal line like this. Start a line from this point in this direction. I will take 43.3 mm line on this direction. So I will enter 43.3. I will press tab button. Then I will enter 30 degree. Press enter. Then I will enter 50 mm length. Press tab. 150 degree. Enter. Then 43.3 mm length. You can enter minus 150 degree also, but you can make use of this parallelism addition also. It is showing me parallelism symbol now. Click there and close it. This is the isometric view of this rectangle now. But we want to draw this triangle. See, triangle edge is here, one of the edge. One of the corners should come here, exactly the midpoint of this. So when I know that corner, I can easily join these 3 points to make the triangle. So go to line command, start the line from this point and identify the midpoint. See, it is showing me the midpoint there. Click there and end the line here. Right click to end the command. Now this is the triangle which we wanted, which is representing the isometric view. I want to convert this into isometric projection by reducing the scale. So go to scale command, scale, select this entire view, enter the scaling factor as 0.8164 and click at this point. See, now it is reduced to isometric scale now. All these sides are of isometric length now. And you highlight this triangle by changing the thickness of the lines to 0.5. Show the angle between these two lines. Right click, select these two lines, place the angle like this. Now this is the completed isometric projection of the equilateral triangle. Next example is the isometric projection of a pentagon of sides 30 mm. Just like triangle, here also we need to construct a two-dimensional view of a pentagon. We'll start like this. Click on line command. Draw a horizontal line of 30 mm. This, click there. Next 30 mm, I want to make it 72 degree. Next 30 mm, 72 into 2 degree. Next 30 mm, 72 into 3 degree. And just close it. This is the easiest method to construct a regular pentagon. You can use other methods also. Show the distance of this 30 mm and I will name these corners A, B, C, D, E. This naming is only for your understanding. It is not required in the actual drawing. Now I have to enclose this pentagon inside a rectangular box. Go to line command. You can start anywhere. I will start here. Horizontal line till this point. Go vertical till this point. Click there and go vertically upward till this point. Click. Come horizontally like this. Horizontally extend it like this. Click there. Go vertically down. Click there. And go vertically down, click here and close it. Right click to end the command. Now you see pentagon is totally enclosed inside a rectangular box. You can zoom this area and check whether it is properly on the line. Now I will call these corners as F, E, H and I. I will show these dimensions, this total distance from here to here, 46.17, and total distance from this line to this line, this one, 48.54. Distance of this E from the horizontal bottom, distance of the point A and F, this distance. All these distances are required in order to draw the isometric view or projection. With this detail, I can start the isometric view first. So draw a horizontal line and start from any point. You can take 46.17 mm side or 48.54 mm side. I will take 46.17 side, 46.17 length, angle is 30 degree, then 48.54 angle is 150 degree, then again 46.17 angle is minus 150 degree and close it. This is what is a isometric view of the rectangular enclosure. Now just for the reference, I can show that this is point G, this is point H, this is point I and this is point F. Just see GH length is 46.17 which is here, and IH length is 48.54 which is here. So this enclosure is drawn now. Now I have to mark the points A, B, C, D, E on this enclosure. To do that, first I will make use of this distance 28.53. I can locate point C here. For that I will draw line from this point but with a length 28.53 like this. See, now the resulting point is nothing but point C. Now if I draw a line like this parallel to this, if I click here, now I am getting the other point E also. E will be here. This is point C, this is point E. And you see this distance, if I click on this line now, this distance is 28.53. Then the point D is a center point of IH, right? So I can easily mark that point. Before that, point A and B are on FG, means on this line. And what is the distance of F and A? It is just 9.27. I will go to line command. I will start from this F. I will enter 9.27 as a edge length. I will click here. I will right click to end the command. and I will start another line from point G. I will write 9.27 side length for this also. I will click on this line again. I will right click. So what did I do? I know that FA distance is equal to BG, right? So GB is here. If I click here, you see line it is showing it is of length 9.27, means I have a point here. That point is B. I will show that point here. So point B is here. Similarly, if I click on this line, it shows a point here which is nothing but A. So point A is here. And one more point that is required is point D, that I will automatically get once I draw the line. Say I will start the line from this point B. See, it is showing the end point of that line BG. So click there, then click on this point, then click on the midpoint of this line. See, automatically I am getting point D there. Click there, then click on E, then click on A and close it. Now this point is point D. This is the isometric view of the pentagonal lamina. Isometric projection I want, so I will scale it down. I select everything like this. We'll say 0.8164 and I will place at the same point. Now you darken the sides of the pentagon. You show the angle between this line and this line, angle between this line and this line. That completes the isometric projection of pentagon of sides 30 mm. Next problem is to construct the isometric projection of a circle of diameter 60 mm on a horizontal plane and also on vertical plane. You all know that when a circle is inclined to any plane, it looks like an ellipse. So we need to construct the ellipse to represent the isometric projection of a circle. And to construct an ellipse, there are different methods. One of them is 4-center method of ellipse construction. I will show you the ellipse construction by 4-center method on all three different planes on the isometric axis. First, I will draw it on horizontal plane. Go to line command. Draw a horizontal line like this and start the line from this point. You know that diameter of the circle is 60 mm. So draw a line of 60 mm with 30 degree. Then 60 mm length with 150 degree. Then 60 mm with minus 150 degree and close it. This is the box within which I have to construct the ellipse. To construct ellipse with 4-center method, the procedure is like this. Draw a line from this point to this point. You can call it as leading diagonal. And then draw a line from this corner to the midpoint of this line like this. Right click and draw another line from the same corner to the midpoint of this line. Click there, right click. Now you have got 4 centers. I will name all those 4 centers. This can be called as C1, this can be called as C2, this can be called as C3, and this can be called as C4. These are the 4 centers using which I have to draw the ellipse. And ellipse will be constructed by using 4 arc segments. I will go for arc command. See, arc by center point option, last option in the arc command. Click on that. I will use C1 as a center first. See, I am clicking C1 as center. Then I will start from this point, click there and draw the arc like this. And it should end at this point. What did I do? This is the arc I have drawn with C1 as a center. Similarly, I have to draw an arc here with C2 as the center. See, I am going to the same command. Click on arc by center point option. Click on C2 point first. Then start the arc from the midpoint of this side or midpoint of this side. So I am clicking on the midpoint of this side. Then I am starting the arc and it should end at this midpoint. Click there. Now you see this is the second arc I have drawn with C2 as the center. Then I should draw another arc with C3 as center. So click on arc by center point option and select the intersection point here. See, you have to select intersection point only. That is the point C3. Click there and start the arc from this end. Click there and draw an arc like this. And that should end at this point. So this is the third arc I have drawn with C3 as a center. Similarly, C4 as center, I have to draw another arc. So click on arc by center point option. Click at this intersection point first. Then start the arc from this point or this point. This. Sometimes your command will not work properly like this. So if it comes like this, you click there and you have trim command. You can use trim command and trim this portion. And this portion you select and delete it. And this portion of the arc needs to be extended till this point, for which you have one command. You go to trim command. Below that there is an option called extend to next. Click on that and click on this arc. It completes the arc. Okay. This is the method for constructing 4-center ellipse. Now you can show 30 degree here, 30 degree here, and you can reduce the scale. Now it is isometric view. You can reduce the scale to isometric projection. I am selecting all this and reduce the scale 0.8164 and place it. I will darken these 4 arcs. The same ellipse can be constructed on a vertical plane also. Let us consider the right vertical plane first. I will draw it here. I will draw a horizontal line first. Then I will start a line from some point and 60 mm 30 degree. Then I will draw a vertical line now. I will not draw 150 degree line, but I will draw 90 degree line like this, because I want to construct the ellipse on a vertical plane, right vertical plane. So I will enter 60 mm, but I will enter 90 degree now like this. Next 60 mm, I will draw parallel to the originally drawn line, or you can enter minus 150 degree. Click there and close it. Now this is the box inside which you have to fit the ellipse now. So as usual, I have to draw a leading diagonal first. So I will draw leading diagonal from here to here. Right click. Then from this corner, I will draw a line to the midpoint of this line. Right click. From the same corner, I will draw a line to the midpoint of this edge. Click there. Right click. Now you got 4 centers. I can call this as center 1. I can call this as center 2. I can call this as center 3. And I can call this as center 4. Using these 4 centers, I have to construct the ellipse now. So go to arc by center point option. First I will use C1 as center. Click there and start the arc from this point. Draw it till this point. Click there. So first arc is drawn. Observe this C1 is the center for this arc. Now I have to draw another arc from C2 as center. Click there and midpoint of this edge as a start point, or midpoint of this edge as a start point. So click there and draw an arc like this. Click here and go to trim command. Trim this portion and delete this portion of the arc and go to extend to next option and select this like this. So 2 arcs are drawn. Third arc I will go for C3 as center. Click here. Start the arc from this point and draw it till this midpoint. And C4 as center. Start the arc from this point and draw it like this. This is the isometric view. I will reduce the scale to isometric projection. Select all these. Enter the factor as 0.8164 and click here. Now change the line thickness of all these arcs and you show this angle as 30 degree. That's the isometric projection of a circle of diameter 60 mm on a right vertical plane. Same can be constructed on left vertical plane also. I'll show it here. Draw a horizontal line. Start the line from this point. We'll enter 60 mm 90 degree first. this, then 60 mm 150 degree like this I should enter. So 60 mm 150, then 60 with 90 degree like this, click here, close it. So this is the box inside which I have to construct the ellipse now. Again, force enter method I will use. Line command, join this to this, join this to the midpoint of this line, join the same corner to the midpoint of this line. Now you have 4 centers. You may call this as center 1, this as center 2, this as center 3, and this as center 4. Using these 4 centers, I have to draw an ellipse now. So go to arc by center point option, select C1 as center and this point as starting point. Draw an arc like this. I will use trim. I will trim this portion and I will delete this portion of the arc. I will use extend to next option like this. I will use arc by center point option again. I will select C2 as the center now. Midpoint of this edge or midpoint of this edge as starting point, I should start an arc like this. So again it is creating arc like this. For trim command, I will trim this portion. I will delete this and I will use extend to next option and extend it like this. Then arc by center point with C3 as a center, this as a starting point. We'll draw an arc like this. With C4 as a center, this as starting point, draw an arc like this. This is isometric view. I will scale down 0.8164 and click there only. And highlight the ellipse and show this inclination. That's the isometric projection of the circle on left vertical plane. Next example is construct the isometric projection of a hexagon of sides 30 mm on a horizontal plane and a vertical plane. I will take the first case, horizontal plane. Before drawing the isometric view, we need to construct the hexagon first. Click on line command, 30 mm 0 degree, next 30 mm 60 degree, next 30 mm 60 into 2, next 30 mm 60 into 3, next 30 mm 60 into 4 and close it. This is the quickest way of completing a hexagon and I will show the dimension here. This is 30 mm side. I need to enclose this inside a box, so I will start a line from this point. Just click here, click here, click here, click here, and I will start from line corner here, click here, click here, click here, click here. Now I have enclosed the hexagon inside a box. Now I need this dimension from here to here. I want to know, and from here to here it should be 60 mm. It is 60, and I also want to know this edge length 25.98, and I need this length also. So all these I want to use in constructing the isometric projection. Now I'll go for line command. I will start isometric projection first. I will start a line from this point, and I will take 60 mm on this side. So 60 mm 30 degree. Next on this direction I will take 51.96 with 150 degree. Next 60 mm minus 150 degree and close it. Now you can imagine this corner has come here and this 60 mm length has come here and this line is here and so on. Now I'll start line command from this corner. I will mark 15 mm length. I will click here, right click. From the other end also I will draw 15 mm length because that will also be equal. Click here. Then if I draw from the end point of the newly drawn line, a line like this, we'll get the other 2 points also opposite side. The end of this 15 mm line also, I can draw a parallel line. So I got 1, 2, 3, 4 points of the hexagon. Other 2 points are the midpoint of this line and midpoint of this line. So I will draw a line from the midpoint of this, the midpoint of this. Now I have to draw the hexagon. See, I can start from any point. I will start from this. I will join it to this, join it to this, join it to this, join here, join here, join here. See, now this is the isometric view of the hexagon, but I have to convert it into isometric projection. So I will reduce the scale and select it, 0.8164 reduced, and I will highlight these sides of the hexagon, 0.5, and I will show the angle between these two, That completes the isometric projection of the hexagon, a horizontal plane. On a vertical plane, if you want, you can draw it on left vertical plane or right vertical plane. I will draw it on left vertical plane first, like this, horizontal line. Then I will take a vertical line of 51.96, and then this line should be 60 mm, but angle 150 degree. Then 51.96 mm length vertical, and close it. You should remember that this is the shorter length and this is the 60 mm length. This is 51.96, this is 60 mm. Now I'll start line from this point, 15 mm here, click here and draw a parallel line to this, and I will draw another 15 mm from this end, click here and draw a parallel line like this, and just join the midpoint of this edge to midpoint of this edge. Now you have 6 corners of the hexagon, you just join them. And you have to reduce the scale, select it, 0.8164, place it here. Show the angle between this line and this line and darken the edges of the hexagon. This is the isometric projection of the hexagon on a left vertical plane. Same can be constructed on right vertical plane also. So given a hexagon of some size, we can draw it on horizontal plane or on a left vertical plane or on a right vertical plane. Any of the lamina, in fact, we can draw it on any of these 3 planes. Next exercise is to construct the isometric projection of a square prism of base sides 40 mm and height 60 mm. You know that square prism is a solid, and the usual practice to build isometric projection of a solid is to start from the base and give the height. Go to line command, draw a horizontal line and start the isometric view of the bottom face of the square prism, which is a square of sides 40 mm. So I'll start from this point. We'll draw 40 mm 30 degree, then 40 mm 150 degree, then 40 mm minus 150 degree and close it. This is the isometric view of the bottom face of the prism, but the height is 60 mm. So I will give the height for one of the corner. Height is always vertical, so I will give height of 60 mm here. Now you see all these four sides are 40 mm and this is the height which is 60 mm. Now I have the move command. I can move this face from this point to this point and make a copy there, because top face is similar to bottom face in square prism. So move command, copy option is on. Press control button and select all these four sides. Leave the control button. Select this point as starting point and select this point as a end point. Right click. Now we have copied the bottom face to top face. Now join these corners, the base points like this. That completes the isometric view. We have to scale down to make it isometric projection. So go to scale command, select this entire view, go to 0.8164 scaling factor and click here. It is scaled down to isometric projection now. Now we have to indicate the visible lines. Start from the topmost face. Topmost face is visible always. So select these four lines. These four lines represent the top face. Darken them. Then these four lines form the boundary. They are also visible like this. And the edge in the front, this is also visible because this face is visible, this face is visible. The edge or intersection edge should be visible. This also should be visible. So this completes the isometric projection of the square prism. No need to delete other lines. For example, this line and this line, they are invisible lines. Don't change anything or delete it. Leave it as it is. This is the completed projection. You can give the angle 30 degree here, 30 degree here. That's the end of the projection.